Offshore wind will see a massive investment in Europe in the years to come. Within 2050, it will increase by 13 times.
So we got these windmills, which are producing green power, and at the same time, the cooling systems on the HVDC platforms are consuming significant amounts of energy, which is unnecessary. You have a very high energy consumption, which results from pumping all the seawater up on the platform, or it's just dumped back into sea.
The problem with the current cooling systems is that you have an open loop cooling system, which means that you have emissions to the sea.
You have to add hypochlorite to that system to avoid marine fouling in your seawater system, which again releases a lot of hypochlorite to sea.
You need to have maintenance, regular maintenance, so you need to get people on board with helicopters or boat, and they need to stop, you might even have to stop the production of electricity.
We know a subsea cooler technology that can have a solution of all these problems.
By removing the need for the seawater lift pumps, we've taken away a lot of the power consumption on the HVDC platforms. And on a typical example, we've cut the power consumption by 6 million kilowatt hours per year, which is equivalent to 1,400 tons of CO2 emissions per year.
We created a calculation tool called SimCool, which accurately calculates the cooling performance, and by that you are able to do design optimizations very quickly.
That software has been thoroughly verified with large-scale prototype testing. And then to adapt this to the offshore wind industry, we have done with 5 years of performance data for the materials we're using.
I think the fact that there is a closed system, not emitting any gases or fluids during operation, is a key aspect. It's simpler, it's smaller, and it's more effective. It's a big step in the right direction.
The solution is quite easy to install. You have to have the piping subsea, and then you use often the deck crane or a supply vessel in order to lower the cooler down into the frame that is installed either on the jacket or on the template subsea.
This FSEC solution has 30% lower investment cost and 75% less energy use. That compares to 1,400 tons of CO2 equivalents per year.
We believe this to be the future of offshore cooling, and that this will be the predominant way of cooling offshore platforms in the future.